Today we're going to talk about the separation of solutions and mixtures chromatography. So let's start with paper chromatography. It's the most common that you'll see on the AP Chemistry exam because it has the simplest materials involved. Essentially, you're going to start with water or some kind of solvent, but it's typically water. And you'll have a mixture on a piece of paper. And you put the paper into the water, and the water will start to move up the paper. And it does this using intermolecular forces. And as the water is drawn up the paper, when it encounters the mixture gets drawn up with the water. Now, different materials in the mixture will have different intermolecular forces with water. And the ones with the strongest attractions to water will move the furthest up the paper. So like in this case, this yellow spot has the most attractions out of the mixture because it travels the furthest up. Now, of course, this would be different if you used a different solvent. Sometimes they'll try to throw you off by using like a non-polar solvent and ask you about polar and non-polar substances in the mixture. But just be aware that typically it is water as a solvent, just not always. And so then the one with the strongest intermolecular forces with water will move the furthest up. The one with the weakest intermolecular forces with water will end up close to the starting point. Thin layer chromatography works almost the same as paper chromatography. The difference is you'll have a plate, and sometimes they'll use glass, sometimes they'll use some kind of polymer, but there'll be a plate, like a clear plate, and then there'll be some kind of coating on top, and it makes a very thin layer. That's why it's called thin layer chromatography. And so this thin layer has some kind of material on it that the substance can move through. So what you'll do is you'll spot the plate, which means you'll put just a little bit of the dye or the mixture onto the plate, and then you'll sit it upright into your solvent, which is sometimes water, but it could be another solvent, depending on what you're testing. Then when the plate is in that solvent, the solvent goes to move up the plate, and when it interacts with the substances will attract the solvent and move up the plate with the solvent. And so the distance that the solvent travels is called the solvent front. And then we have a starting point. From here we can calculate what's called the RF value, or the retention factor. Okay, retention factor is the distance that the solute traveled over the distance that the solvent traveled. So the solute is whichever thing in your mixture. So you can calculate an RF value for this first one by doing the distance that the red spot traveled divided by the distance that the solvent traveled. Then you can find another RF value for the distance that this blue spot traveled divided by the distance that the solvent traveled. So that way we can compare using this RF ratio. We can compare the attractions of the substance to the water. We can also start to analyze what those substances in the mixture are. So for example, in this picture, you'll see that there are two things in your mixture. Now, because it traveled the same amount, so this first dot traveled the same amount as dye number 3, we can conclude that the mixture is made up of dye number 3, and it also has some dye number 1 in there, but none of the dye number 2. So you'll have like some reference samples, and you'll have your substance that you're analyzing. But you'll see that if you calculate the RF value, it'll be the same for identical substances. Okay, the last type of chromatography is called column chromatography. This one is unique because it actually allows you to collect the substances that are in the mixture instead of just observe or analyze them. So what you do is you have a column, which is typically like a burette or a big test tube that has openings on both ends, right? And you'll pack it with what's called the stationary phase. Sometimes it's like a silica gel, sometimes it's just, you know, whatever the material is, it's going to pack in there, and it's usually a solid. Okay. Then you're going to put your mixture at the top of the column, and you're going to add solvent. And the solvent ideally will go through very quickly. So if your stationary phase is polar, then your mobile phase or your solvent will need to be nonpolar so that they don't interact very well. But then as it travels through, the solvent travels through, whichever part of your mixture is most attracted to the solvent will travel through first. So if you're, let's say for example that your stationary phase in this one is nonpolar, and your solvent then should be polar. And as you're putting the polar solvent through, the one that is most polar will travel with it. So the yellow, in this case, will be more polar because it's traveling with the polar solvent. And then as it moves through, you're able to collect at the bottom that yellow substance, that part of your mixture. And then if you kept going, you could eventually collect the other substance. So again, this is unique because we can actually collect the substance out of the column, whereas in paper or thin layer chromatography, it's just to analyze the components. A way that we can separate mixtures based on their boiling points is called distillation. So this is a basic distillation setup. And in this flask over here, you will have a mixture of two liquids, and the two liquids should have different boiling points. It'll typically either be a water bath or a sand, like a sand pit. I don't know how to have a better word for that. But you'll submerge that, and then you'll heat that up. And you want to heat it up slowly. And whichever substance has the lower boiling point will start to evaporate first. You can kind of see the particles starting to evaporate here. You'll have a thermometer to track the boiling point, but the lower boiling point substance will evaporate first. When it gets to the top here, it's going to travel down what's called the condenser, and it's called a condenser because it changes the gas into a liquid. Condenser usually has space for water to surround, and it's essentially a water cooling system. The water goes in at the bottom and out at the top, so you have cold water coming in from the sink, and it's cooling down the gas. And as the gas becomes a liquid again, then it is collected in this flask at the end of the process. So when it is completely separated, you're left with the higher boiling point liquid in your original flask that's left behind, and your lower boiling point liquid is collected in the new flask. And that's how you separate them using distillation.